In this video, you're going to learn how to find the total effective resistance. In other words, it's the combined resistance for the circuit. And you can see here, there are three resistors connected in series. Now, this is just part of a circuit. You can imagine this is connected to a battery, and these three resistors, they are connected in series where there's only one path in which the current can flow. So to find the total effective resistance, we put there RE. And if they are connected in series, it's very simple. You just need to add them up. So the total effective resistance will be 10 ohms. So in other words, if I were to simplify the diagram, this is equivalent to one single resistor that is 10 ohms that's connected to the battery. Now in example B, you can see that this 2 ohms and 3 ohms resistor, they are connected in parallel. Meaning to say the big river or big current comes here, it will split into two smaller current here, and 2 ohms and 3 ohms, they are parallel branches. So to find the total effective resistance, so you just take 1 over RE because now it's in parallel. So I will take 1 over 2 because this is 2 ohms plus 1 over 3. And you'll get that the answer is 5 over 6. Alright, and take note, the total resistance is RE. Right now is 1 over RE. So what you need to do is just flip it over, which is 6 over 5, and the answer is 1.2 ohms. Don't leave your answer in fraction. So that will be the answer. Of course, you can also choose to just put there RE, finding the total effective resistance directly. Then there will be 1 over 2 plus 1 over 3 to a power of -1. That means you do the inversion here and the answer will be the same and you get the answer directly. So just remember, you need to invert back. So once again, it's the same as this circuit is equivalent to, since I combine these two resistors together, is equivalent to one single resistor which has a resistance of 2 ohms. Now I want you to pay attention to something. Whenever the resistors are connected in parallel, you can see that the total effective resistance, the combined resistance, is actually smaller than even the smallest one over here. So that's one way to check also. So in general, when you connect the resistors in parallel, you're going to make the total resistance even smaller. Now in the next example here, alright, you can see that some students are a bit confused because of the way it's drawn here, but take a look at this. This is like a big river. When it comes to here, it can split into here, here, or here. That means to say this branch, the 6 ohm branch, 4 ohms branch, and the 3 ohm branch, they are connected in parallel. So if I were to draw it, simplify the diagram for you, is similar to this is my 6 ohms, this is my 4 ohms, and this is my 3 ohms. Then these three branches, they're going to combine back to form the big river again. So this is the same which you are familiar with. So next, let's find the total effective resistance. So 1 over RE is equals to, because now there are 3 in parallel, so I just take 1 over 6 plus 1 over 4 plus 1 over 3, and you'll get 3/4. And remember, you're finding RE, so you just need to invert, and therefore it's 1.33 ohms. Alright. In example D here, you can see that these two resistors, they are connected in parallel, and you're supposed to do this first. So in other words, you're going to find the total effective resistance of these two to combine them together. Then this 4 ohm resistor and this 4 ohm resistor, they are all connected. Then these three here, they are connected in series. So we do step by step. Let's do the part where they are parallel. So to make it simple, I don't put RE here, I put R parallel to represent I'm finding the total resistance for these two. So it's 1 over 4 plus 1 over 5, and you'll get 9 over 20. So R parallel will be 2.22 ohms. So in other words, this is 2.22 ohms in series with this 4 and 4. So the total effective resistance will be 2.22 plus 4 plus 4, and you have a 10.2 total effective resistance. Now in this example here, you can see that this branch here and this branch, they are parallel. So if you take a look here, the big river, the big current comes to here, it will split into these two, and then they will join back to form the main current again. So first of all, what I can do is combine these three that are in series. So as you know, they are in series, I can just add them up. So this is 4 ohm resistor, and the other branch will be a total of 5 ohms. So if I have to simplify the diagram, this is equivalent to a 4 ohm resistance and a 5 ohms resistance. They are connected in parallel. So the next step I need to do is to find the combined resistance of these two. So 1 over RE is equals to 1 over 4 plus 1 over 5. You'll get 9 over 20. So RE will be 20 over 9, 2.22 ohms. Alright. So take note of this. You have to do the series first, and then this series, only then you combine the two in parallel. Okay, for the next one, so it may seem a bit complicated, but if I were to redraw the diagram for you, this is the big river, so this is 3 ohms, and when it comes to here, it has a choice of 1, 2, 3. It will break into 3 branches, and these two are in series in this branch, so I can straight away know that this is 2 ohms because they're connected in series. I just add them up. This 2 ohms is just there in this branch, and for this branch here, once again, is in series, so I can just add them up, and you will realize that this basically the 2 ohms, these 2 ohms here, they are connected in parallel. So I have to do this part first, then this whole thing is in series with the 3 ohm resistance. So in other words, so this is 3 ohms, and then I need to find the combined resistance of this parallel. So this parallel will be referring to this. So 1 over R parallel is equals to 1 over 2 plus 1 over 2 plus 1 over 2, and total is 3 over 2. So R parallel for the 3 in parallel, the 2 ohms, so it will be 2 over 3, so it's 0.67 ohms. So how do you then you find your total effective resistance? Because this is 0.67 and is in series with the 3 ohm resistance, I just add them up. So total will be 3.67 ohms. Alright, let's go to the next one. Once again, seems a bit complicated, but it's actually very simple, even though there's diagonal resistors or branches. So once again, the big river comes here, ask yourself, it will be split into 3 different branches, and the 3 branches are parallel to one another. So in other words, if I were to simplify the diagram, so it's big river comes here, it will split into 3 individual branches. Okay, so these two, in this branch, there are only 1 ohms and 3 ohms connected in series. So I can just mentally combine them, 1 plus 3, that will be 4 ohms. And now in this branch, there are 3 ohms and 2 ohms in series, so I add them up mentally, so this will be 5 ohms. And the last one, the last branch over here, is a 2 ohms, and there's only one single path, so these two are connected in series, so total is 6 ohms. So we can see it's actually a very simplified diagram. These 3 are now connected in parallel. So as per normal, you want to find the total effective resistance. 1 over RE is equals to 1 over 4 plus 1 over 5 plus 1 over 6. And that will give you 37 over 60. So RE, remember to invert back, will be 60 over 37. That will be 1.62. Now in one last example which I have drawn here, if you look at the diagram, it seems like resistor 1, 2, and 3, they are connected in parallel because of the way they are drawn. But actually, if you understand the river system, all right, the big river comes up from here, the conventional current comes up from here. Once it reaches this point, it will split into these 2 branches. That means to say, if I were to redraw it for you, the big river comes to this point, it will split into two. Okay, this will be 2 ohms, the number 2 resistor, and this is the number 3 resistor, after which they will join back to a single point, and then after that it will pass through resistor 1 and then go back to the negative terminal of the battery. So if you were to redraw it yourself, it's very clear that resistor 2 and 3, they are connected in parallel. So you do this part first, then the number 1 resistor is in series with these two, so then you add them together. So don't be tricked by the question. So I hope with this video you have a better understanding in finding the total effective resistance. Alright, thank you.